So in this video we're going to show two examples of converting a rectangular equation into a spherical equation. So here I have a rectangular equation, x squared plus y squared equals z squared. Rectangular because it has x, y, and z. And we want to convert it into spherical, so we need to wind up with an equation that is described only in terms of rho, theta, and phi. And when you look at this, your first option would be to say, hey, here's x squared, and I know from the previous video what the relationship between x, rho, phi, and theta is, so I could just square x and square this mess and substitute this mess in for x squared. I could take and square the y, which would mean I'm squaring this mess, and I could substitute this mess squared in for the y squared, and then I could square the z, and then substitute this squared in for the z. And that would be one way to do it, and we could go through the simplification process and we'd wind up, I believe it turns out to be the tangent squared of phi equals 1, I think is what you get. There's another approach that I think is just a little bit easier, and you wind up with the cosine function, but the result is gives you the same angle results. So when I see this, I want to take advantage of the fact that the sum of the squares of x, y, and z is equal to rho squared. So just coming in here and adding z squared to both sides gives me a rho squared right here. So I get a rho squared equals 2 times z squared. And then I can go ahead and square my z and replace it with rho squared cosine squared of phi. So I get rho squared plus 2 times, and then z squared will be replaced with rho squared times cosine squared of phi. And you can see here, if you divide both sides by rho squared, you get 1 equals twice the cosine squared of phi, which means a half is going to equal the cosine squared of phi. So there's one example. Here's another equation, x squared plus y squared plus z squared minus 9 times y equals 0. So again, you'd want to look at this and right away notice that the sum of the squares of x, y, and z is just rho squared. So you can make a quick replacement there. Rho squared minus 9 times y, but y is just equal to rho sine phi sine theta. So replace that with rho sine phi sine theta, and this is equal to 0. If I add this to both sides, I'd get rho squared equals 9 rho sine phi sine theta, and I can divide both sides by the rho. So we get 9 sine squared phi sine theta. And again, I ignored it a little bit in the previous slide, but I probably shouldn't ignore it too much. If we divide both sides by rho, we're assuming that rho does not equal 0. Rho divided by rho equals 1 if rho isn't equal to 0. So the question is, can you still get rho equal to 0 if you need it from the simplified form of the equation that's left? And if theta is equal to 0, the right hand side is going to 0 out. So if rho equal to 0 is a solution, we didn't lose it by dividing both sides by rho. We'll still be able to get a rho equals 0 type of solution out of this. So I'd say at this point, this looks pretty well simplified. I don't think I would do anything more than that.